Good morning, students. This is Anjali, Assistant Professor, Department of CAC, AIML, IARE, Hyderabad. Today we are going to learn about the point estimation. Before moving to this this session, we will recall previous session in shortly. In last session, we have learned what is empirical rule, 3 sigma, normal distribution, and what is outlier. What is empirical rule? Actually, empirical rule is referred of 3 sigma which is related to standard deviation, related to 3 standard deviation. And this 3 standard deviation you know very well. Which are the 3 standard deviation? 68, 95 and 99.7. These are your standard deviation. And these standard deviation are included in the 3 sigma. Actually, these are your 3 sigma. And these 3 sigmas are like 1 standard deviation, 2 standard deviation, and this is 3 standard deviation. And we know the formula for empirical rule. Empirical rule is equal to mu plus minus multiplier sigma. This is your mean. This is your multiplier. And this is your standard deviation. Then we have seen that a normal distribution, this normal distribution is totally related to probability distribution. Probability distribution. And this probability distribution we have shown in the form of the bell curve, in the shape of the bell. In the shape of the bell. And this normal distribution also we have seen that these sigmas are involving in the normal distribution also, and we can show this data like this. This is your normal distribution, and in normal distribution you are showing this data probability distribution like mean. All these things you will show in the normal distribution. Then what is outlier? In previous class we have seen one example like a batting average of batting. Every batsman has like a 50 was average of 52 to 62. But one batsman was there whose batting average was 90.99 point something. That means when other record you will see all these things are related to each other. All values are close to each other, but this value is totally different. This value is far away from these things. So, this is your outlier. This is your outlier. That means we can say that totally different from the other things, or we can say it is an unwanted thing. But not always it is unwanted, but sometimes it should be unwanted. That's why it is a outlier. Now we will move towards our main topic, point estimation. So this contents we will cover here: estimation in the statistics, point estimation, understand the point estimation, why point estimation is important, point estimation estimate formula, and point estimation of population mean. These points we will cover. Now, estimation in statistics. What is meant by estimation? In estimation, in statistics, actually we are evaluating some parameters. We are finding out finding out some parameters. So all these estimated things are related to something we have to calculate, something we have to analyze. So this estimation has two types. One is a point estimation and another one is an interval estimation. So what is mean by point estimation? Actually, in statistics, your estimation theory and hypothesis testing are very important for determining the solution to certain problems. And this point estimation is one of the areas help people involved in statistical analysis come to conclusion regarding many different kind of questions. That means point estimation is one of the area where 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 the people can involve in statistical analysis for to reach their conclusions related to their questions. And this point estimation defines the calculation where sample statistic used to estimate and or approximate an unknown population parameter. Just we will take one of the example, the average of the height. Average of the height of the random sample can be used to estimate the average height of the larger population. This is your point estimation. That means we are finding out, we are analyzing, we are predicting some conclusions. So in point estimation, we are using some data for calculating the values or point where it can serve as a best guess of any given the parameter that may be unknown. And these estimators define a function that can be used for finding the approximate value related to some particular points where we are using the population as a parameter. And that sample data of the population is used to find out the point estimate. Or we can say we are finding out the statistic that can act based estimate of the unknown parameter. These parameters are unknown and that is given for the population. And the point estimate is a estimate of the population parameter which are based on the sample data. You know the population and you know the difference between the population and the sample. Population is your group. Population is your group and sample is a specific thing from the group. So we are finding out the point estimate. We are calculating the point estimate on the basis of the sample of the data. We use the point estimates to estimate population means, variances and other statistics. So definitely when we are talking about the statistics is containing some means, median, variances, coefficient, then standard deviation. All things are included in the statistics. So to obtain these estimates, we will simply apply the sum functions where we have to measure our population to a sample of the data. Just we will take the one of the examples. Suppose there is a company of 9,000 employees and we are interested in ascertaining the average length of the breaks taken by employees in a single day. For example, suppose we have a company and there are 9,000 employees are working and we have to find out the average length of the break taken by the employees in a single day. But as we probably cannot ask every single, and it's not possible also because the population is so much. It is your population. For now 9,000 is your population. So we can't go to everybody and we can't ask to everybody for break time. So what we will do, just we will take a sample of the 9,000 people. We will take the sample of 9,000 people and we will take the mean of the sample. So this sample mean will be our point estimate. Now understand this point estimation. Actually, the statistical analysis allows researcher and statistician to make to find out the statistical inferences and the generalization. Actually, researchers use the samples for representing the larger populations to determine any observed differences between the groups represent meaningful or real world effect. However, understanding the characteristics of the particular population is critical in determining whether particular research finding from sample can be generalized to the population at a large. So here there is a need to understand the characteristics of the particular population. What we will find out, what research we have to find out, and what we will get, which type of data we are getting. And this is where the concept of the point estimation come into the practice. And there is important distinction between the samples and the population. And students, you know very well the difference between the distinction between the sample and the population. And we have already discussed on it. So researchers and statisticians also use the specific terminology to differentiate characteristics of the sample and population. And we know that the population is the group to which the results of the study are being generalized. That means population is your group. And sample is a small collection of people that are thought to be representative of the population of the interest. That means you will take sample means it's a specific value. It's a specific things from the group. This is your sample. And what is meant by parameter? And the characteristics of the population that is represented by the numerical value, and that is your parameter. And then statistic and the characteristics of the sample that is represented by the numerical value, it is your statistics. When we have to represent the parameter, so at that time we will use the population. And when we have to represent the statistics, so we have to use the sample. So both population and sample are very important in our point estimation. So why we need the point estimation? Actually, point estimate statistics are useful because researchers rarely know certain population parameters. And for example, GPAs of the college students at particular educational institution known because the administration of the institution keep records of that data. And in this case, researchers that want to investigate the something that they think might influence student GPA would have access to that particular population parameter. And however, it's a more often the case that the population parameters are unknown. And when we have to find out the point estimation, there should be population parameters unknown. And this is especially true when the large population are being studied, such as population of an entire country. And in these instances, researchers have various methods of estimating the population parameters for helping them make statistical inferences. Now, there are some point estimate symbols. The following table contains the point estimate symbol that are used for sample statistics and the population parameters. There are data value, average age, proportion of people under certain age, then spread of the age. Then there are the point estimate where find out the sample mean, sample proportion and sample standard deviation. There are symbol X bar, P hat, and a S. Then parameter we are using population mean, population proportion, and population standard deviation. And for this symbol is MU, P, and the sigma. These are your point estimate symbol. So here, first we will see point estimate formula. Actually, there are two types of the formulas that are involved in the point estimates. First is the sample statistic. The first step in calculating point estimate formula is to find the appropriate sample statistics. First step of the calculating point estimate formula is to find appropriate sample statistics, since it is required to estimate the corresponding population parameter. Then just we will take the one example. The mean or average of a sample is used to estimate the mean of a population. Mean, or we can say that the average of the sample we have to estimate, and we will use the mean of the population. And other sample statistics that can be used to estimate the population parameter. That means first to estimate the mean of the population, then to estimate the population parameters like sample variance, standard deviation, then proportion. Now, population parameters. Once the appropriate sample statistic is found, population parameter can be estimated. And the population mean is common parameter that researchers estimate. Population mean, every time there is a need to estimate the population mean. Even researchers also will estimate this thing. But variance, standard deviation, and proportions are also parameters that researchers and statisticians are very interested in estimating these values. Now, how we will find out the point estimate? Population proportion can be estimated by dividing the x. That is, x is the number of times something occurs in a sample by n. That is, and n is showing that the number of people in the sample. Then the survey is administered to a sample of 300 nursing home patients to determine what proportion of them view the resources provided to them probably. Out of 300 patients, 205 of them reported they viewed the services provided to them by their nursing home as a favorable. In this example, we will take x equal to 205 and n equal to 300. So when we will calculate this thing, and when the researchers have studied and they estimated the population proportion, they got the 68.3%. So this 68.3% is your point estimate. So point estimate formula, we can say that x by n, and our x was here 205 and our 300. Now we will see the properties of the point estimators. The following are main characteristics of the point estimator. First, bias. The bias of the point estimator is defined as the difference between expected value of the estimator and the value of the parameter being estimated. What I said, the point estimator is difference between your expected value, what is your expected value, and what you have to find out, that is the bias. And when the estimated value of the parameter and the value parameter being estimated are equal, estimator is considered as a unbiased. And also, the closer expected value of a parameter is to the value of the parameter being measured, that is, the lesser the bias is. So there are three conditions: bias, difference between expected value and the value of the parameter we have to estimate. Then there should be, if both values are different, if both values are equal, so at that time your estimator is unbiased, and if the both values are closer to each other, closer to the expected value, then your bias value is lesser the bias. Now second one is a consistency, and consistency tells us how close the point estimate stays to the value of the parameter as it increases in size. The inconsistency, actually it is saying that if the size is increases, your point is that point estimator, that means that value, how close the point estimator, that the value of the parameter. So it will show the consistency of the data, and a point estimator requires generally large sample size for it to be more consistent and accurate. So you can also check if a point estimator is consistent by looking at its corresponding expected value and variance, and for the estimator to be consistent, the expected value should move toward the true value of the parameter. So properties of estimators: first we have seen the bias, second one is the consistency, then third one is most efficient and unbiased. The most efficient point estimator is one with the smallest variance of all unbiased and the consistent estimators. So the variance measures the level of dispersion from the estimate, and the smallest variance should vary the least from one sample to other. Generally, the efficiency of the estimator totally depends on distribution of the population. How you are distributing the population, on that basis your estimator, efficiency of the estimator is depend. Just we will take the, for example, normal distribution. In normal distribution, mean is considered as the efficient than median. In normal distribution, mean is considered more efficient than median. But the same does not apply in asymmetrical distribution. Normal distribution generally use symmetrical distribution, and mean is very important than the median. But when you are using the asymmetrical distribution, so at that time your data is at that time your mean is not efficient than the median. So we have seen that three properties of the point estimator. One is the bias, second one is the consistency, and third one is most efficient or unbiased. Most efficient and unbiased. Now we will see the interval estimation. The estimation is the method of drawing the conclusion regarding unknown population parameter from a sample. Actually, the estimator is a statistic that is used to calculate the value of parameter that is undefined. And these intervals statistically estimation approaches that employ survey data to generate value ranges that are likely to contain the population value of the interest. And point estimate, on other hand, single value estimate of the population value. That means your estimation method is totally drawing a conclusion regarding the unknown population parameter from the sample. Now, confidence interval are the most well known of the various form of the statistical intervals. And certain types of analysis and scenarios, on the other hand, necessitate the use of various ranges and provide the different details. Actually, interval estimation in statistics is the computation of the interval or set of values within which a parameter. For example, mean of population is most likely to be placed, and the confidence coefficient is calculated by choosing the intervals such that the parameters fall within them 95 or 99% probability. As a result, the intervals are referred confidence interval estimates. So upper and lower confidence limits are the end point of the such interval. So definitely interval has a upper confidence limit and a lower confidence limit. And in comparison to point estimation, which is a single number, interval estimation uses sample to measure the interval of the possible values for unknown population parameter. And in certain way, point estimate is the best estimate of the parameter based on your sample. Any point calculation, it should go without saying that it's not a correct. It's just a guess based on a single random sample. And the point estimate would be expected to differ from sample to sample, and if repeated random sample were taken from the population. So point estimate and interval estimates are the two forms of the population parameter estimation based on the sample data. And the point estimation is very easy to compute. However, the interval estimate is a much more robust and a practical approach than the point estimate. This is your point estimate and this is your interval estimate. And this also we have shown in the bell shape. This is your mean, and this is your point estimate, and this is your interval estimate. Now, interval estimate formula. Mu is equal to x bar plus minus z a by 2 sigma divided by root n. Your x bar is your mean. X bar is your mean. Then z is the confidence coefficient. Alpha is your confidence level. Sigma is your standard deviation and n is your sample size. N is your sample size. Now there are two types, prediction interval and 9-5 prediction interval. Prediction interval, provided that particular values of the independent variable, and a prediction interval is a range that most likely includes the value of dependent variable for a single new observation. And we are estimating the range for individual observation rather than mean value for this sort of interval. And interval means it's your range. It's your range. What range you are predicting. So on that basis, you have to find out the point estimate. And 95 prediction interval means there is a 95% chance that the future observation will fall within the prediction interval if we collect the sample of the observation and measure a 95% prediction interval based on the sample. What is meant by 95 prediction interval means there are 95% chance whatever you have observed that will be your output. That means your output will be 95% will be correct one. And on the other hand, there is a 5% chance that the next observation will not be contained within the interval. That means 95% will be within the interval and 5% out of the interval. So if we take 20 sample and determine the prediction level for each, we can expect 19 of the interval to contain a single future observation while one of the interval will not. So this is your 95 prediction level. That means you are predicting some conclusion. On that basis, you are finding out the interval. So now we will see the point estimate of the population mean. The most fundamental point and the interval estimation process involves the estimation of the population mean. Consider you have to calculate the population mean. Population mean for quantitative variable and the sample mean x, where value of the x provide the point estimate of and can be computed using the data from the simple random sample. So since sample mean is used as a point estimate of the population mean, and some error can be expected due to the point estimate is computed using the sample or subset of the population. And the sampling error is absolute value of the difference between the sample mean x and the population mean mu. And we can write these things. So the probability assumption about the size of the sampling error is included interval estimation. And the basis of the such statement is sampling distribution of the x. In statistics, point estimators and interval estimators are two most common type of estimator. Interval estimation is polar opposite of the point estimation, and we have already seen that. Point estimation and interval estimation. Point estimation means you are concluding only one point, but interval estimation means you are finding out the range and it yields a single value, while latter yields a number of the results. That means when you are talking about the interval estimation, there should be number of so many outputs. There should be so many outputs. But in point estimation, only one output. A point estimator is a statistic that is used to measure the value of the population unknown parameter. And when estimating a single statistic, that will be the best approximation of population's unknown parameter, and it uses the sample data. And in the interval estimation, uses the sample data to measure the range of the potential values for population's unknown parameter. So always keep in mind, in point estimation, you are finding out the only one value, and the interval estimation, you are finding out the range of the values. For example, single value of statistic is a point estimate of population parameter, and the sample mean x, for example, is a point estimate of the population mean mu, and the sample proportion p is a point estimate of the population proportion p in the same way. Now, common methods of finding point estimate. Method of estimation entails using the value of statistic derived from the survey to achieve the best approximation of the population's corresponding unknown parameters. And whenever you want to find out the point estimation value, so at that time you have to use the unknown parameter, and the point estimator can be calculated by using various methods, and each have its own properties and its own set of the values. Given below are two methods to find out the point estimate. First one is the method of moments. It begins with known fact. In method of moments, it will begin with the known facts about the population, and which are then applied to a sample of the population. And here first step is you have to create first equation. First you have to create equation which will connect the population moments to the unknown parameters. That means you have to start with the known fact, and after that after creating the equation, that you have to convert into the unknown factors. And next step, you have to select the population sample. from which to estimate the population movements. Then the sample mean of population movement is used to solve the equation obtained in step 1. First, you have to start with known facts. Then you have to create the equation. After creating the equation, you have to you have to estimate the unknown parameters. After finding out the unknown parameter, you have to select the population sample, and after selecting the population sample, you have to solve the equation which we have got in the first step, and this yields the most accurate estimation of unknown population parameters. And the second one is the maximum likelihood estimators. Maximum likelihood estimator method of point estimation attempts to find the unknown parameter that maximize the likelihood function. In this method, your likelihood function will be maximized by using the unknown parameters, and it takes a known model and uses the values for comparing the data sets and for finding the most suitable match for the data. Just for example, researcher may be interested in knowing the average weight of babies born prematurely. Since it would be impossible to measure all babies born prematurely in population, and the researcher can take sample from one location, because weight of the preterm babies follows a normal distribution, and the researcher can use the maximum likelihood estimator for finding the average weight of the entire population of preterm babies based on the sample data. So this is all about the point estimation. Last, we have seen two methods to find out the point estimate. First one is the method of movements, and another one is a maximum likelihood estimator. In method of movements, we will start with the known facts, then we will create equations. After that, we will convert it into the unknown factors. Then we will select the population sample, and after selecting the population sample, we will solve the equations and we will get the particular value for the unknown population parameter. And after that, in maximum likelihood estimator, your likelihood function, your parameters will increase by using the likelihood function, and on here you can use the normal distribution also, so you will get the particular point estimate. This is your references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.